All right, so this is our second introductory topic. We're going to talk about mixed numbers. This comes from section 2.2 of the textbook. In the last presentation, we talked about improper fractions. Remember, an improper fraction is a fraction with a numerator greater than or equal to the denominator. Now let's go ahead and introduce mixed number. Mixed number is a combination of a whole number and a proper fraction. These are two things that we're going to interchange, and there are going to be times that we want our numbers as mixed numbers and times that we want them as improper fractions. But they represent the same amount. So let's go ahead and look at just a very basic example and see what we can do here. Let's start off by writing it as an improper fraction. Remember that with an improper fraction, we want the number shaded. So we got 1, 2, 3, 4, 5. Over the number of pieces per rectangle. We have 3 pieces in each rectangle. So now let's go ahead and write it as a mixed number. As a mixed number, we have one whole rectangle shaded. That is going to be our whole number. Plus, we have 2/3 shaded. So one thing to be very careful about when we talk about mixed numbers is note that 1 and 2/3, this is actually equal to 1 plus 2/3. Make sure that you don't think of it as being a multiplication. It is not a multiplication, it's actually an addition. Okay, so these two things represent the same thing. So now we want to talk about how do we convert back and forth between improper fractions and mixed numbers and vice versa. So one thing to note, 3 goes into 5. Remember that we can treat our fraction bar as a division bar. 3 goes into 5 one whole time. We are left over with a 2. We'll see this in a few minutes. All right, so let's go ahead and dive into the procedures for each one of these. So the first direction that we're going to go is we're going to go from improper fractions to mixed numbers. And just like I mentioned on the last slide, in order to do this, we're going to use long division. We want to divide the numerator by the denominator. And now let's figure out where everything goes. The quotient, the result, is the whole number. The remainder becomes the numerator, and the denominator stays the same. So let's look at some examples of this and see what we can do. If we look at example A, let's go ahead and set up our division problem. $17 goes inside, 5 goes outside. And so now how many times does 5 go into 17? It goes in 3 times. We multiply, we get 3 times 5 is 15. Subtract, we get 2. So before we used remainder notation when we did division, and so now we're going to introduce the new notation when we talk about division, which is mixed number notation. So what this is going to translate to is 5 goes into 17 3 whole times. That's my whole number. My remainder becomes the numerator, and my denominator stays the same. Trick a student once showed me was the checkmark method. In the checkmark method, this is how we read it: 3 and 2/5. Whatever way you use to remember it, it doesn't matter to me as long as you remember it. All right, let's try some other examples. Let's look at example B. Example B, we have 5/2. And so if we go ahead and divide, two goes into 5 2 whole times. 2 times 2 is 4. Subtract, we get 1. So as a mixed number, 2 goes into 5 2 whole times. My numerator is the remainder, which is 1. My denominator stays the same. Or again, using the checkmark method, 2 and 1/2. All right, let's try 33/5. We're going to divide. 5 goes into 33 6 times. 6 times 5 is 30. Subtract, we get 3. So we get 5 goes into 33, 6 whole times. My remainder, or 3, becomes my numerator. My denominator stays the same, so we get 6 3/5. All right, so we can also have negatives when we talk about improper fractions and mixed numbers. And so let's see what happens with problems involving negatives. One of the first things to keep in mind is that this negative is applying to the whole fraction. So what we're going to do is, in terms of our computations, we're going to ignore the negative. So I'm going to just divide 15 by 7. 7 goes into 15 2 times. 2 times 7 is 14. And 15 minus 14 is 1. So 15/7, this is equal to 2 and 1/7. And all I'm going to do is bring my negative over into my answer. So we get -2 and 1/7. Let's try one more. Let's look at -35/4. If we go ahead and divide, again, we're going to ignore the negative. 4 goes into 35 8 times. 8 times 4 is 32. Subtract, we get 3. So 35/4 is equal to 8 3/4. And I want to keep my negative. Okay, that is improper to mixed numbers. When we get into the section involving mixed numbers, if you're working with mixed numbers, you always want to write your answer as a mixed number. And so in terms of computations, we rarely work with mixed numbers. That's when we're going to want to convert into improper. But as I said, our answer, we always want our answer as a mixed number if possible. All right, so with that in mind, let's go the other direction now. We want to convert from mixed numbers to improper fractions. So in order to do this, we're going to do kind of an around the world problem. What we're going to do is, starting on the bottom, we multiply the denominator by the whole number. We want to add the numerator onto the product, or what we got when we multiplied. And the result is the new numerator. We keep the denominator the same. So let's see kind of how this works. If we look at example A, as I said, starting on the bottom, I want to multiply 2 times 3. That's equal to 6. Add 1 onto the result, and we get 7. That's my new numerator. My denominator stays the same. So we get 7 over 2. Let's try a couple more examples. Example B. Starting on the bottom, we're going to multiply 3 times 3. We get 9. Add 2 onto 9. We get 11 over. Keep the denominator the same, so it's going to be 11 over 3. Let's try one more basic one. Let's try example C. Starting on the bottom, 10 times 4 is 40, plus 7 is 47, over, keep the denominator, we get 47 over 10. Okay, so now let's go ahead and bring in our negatives. So just like on the previous slide, the negative has nothing to do with our computation. We're just going to keep it in the end. So be very careful with this. Make sure that when you do this, you are not multiplying, for instance, 4 times negative 5 and adding positive 3. It doesn't work that way. So if we go ahead and do this, remember, ignore the negative for now. 4 times 5 is 20, plus 3 is 23, over, keep the denominator, keep the negative sign. So we get negative 23 over 4. All right, last one, example E. If we go ahead, again, ignore the negative. 6 times 8 is 48, plus 5 is 53, over, keep the denominator, and keep the negative sign. Now when we get into the section involving mixed numbers, our first step is always going to be convert to improper fractions before we perform our computations. And so we will be going back and forth using both of these techniques when we get into that section. All right, so that takes care of this section. We have one more introductory material section before we dive into our operations. The next thing that we're going to be looking at is greatest common factor. So go ahead, take a break, and I will see you again shortly.